Welcome to this presentation on cylinders, cones, prisms, and pyramids. Today we will be learning how to find the surface area and volume of commonly used solids. A cylinder is a prism with a circular base of radius r and a height h, which is the distance from the bottom base to the top of the cylinder. In order to find the surface area of a cylinder, we use the equation surface area equals 2 pi times the radius squared plus 2 pi times the radius times the height. If I want to find the surface area of a cylinder with a radius of 7 and a height of 5, I substitute 7 for r, 5 for h, simplify, and find that the surface area is 527.8 units squared. Surface area is an area. It's really a two-dimensional shape, so our units are always squared. To find the volume of that same shape, I would use the equation volume equals pi times the radius squared times h. So again, I would substitute 7 for the radius, 5 for the height, simplify, and find that the volume of this cylinder is 769.6 units cubed. A rectangular prism is a shape that we often think of as a box, but it can be described as a stack of rectangles. So a rectangular prism has 3 dimensions: a height, a width, and a length. To find the surface area of a rectangular prism, we're really finding the area of each of the 6 sides and adding them together. So the formula is surface area equals 2 times the quantity, width times height, plus length times width, plus length times height. So if we have a rectangular prism with a width of 4, a height of 6, and a length of 10, we would substitute 4, 6, and 10 accordingly, simplify, and find that we have a surface area of 248 units squared. And again, it's squared because it's surface area. To find the volume of this same rectangular prism, we use the formula volume equals the width times the height times the length. So we substitute the 4, 6, and 10 accordingly, and we come up with an answer of 240 units cubed. Volume is a 3-dimensional space, and so the units will always be cubed. A triangular prism can be thought of as a stack of triangles. A prism in general is always a stack of a particular shape. We can have prisms that have bases which are pentagons or hexagons or any shape. The last one we looked at happened to use a rectangle, and this one uses a triangle. So we are interested in the dimensions of height, base, and length. To find the surface area of a triangular prism with a base of 7, a height of 9, and a length of 10, we use the formula surface area equals the base times height plus 3 times the base times length. The 3 is there because we really have 3 rectangles that form the sides of the prism, and a rectangle has an area of base times length. The first component, base times height, is there because we are looking at a triangle, and the area of a triangle is 1/2 the base times the height. But because a prism has 2 ends, we need 2 times 1/2 base times height, which yields base times height plus 3 times the rectangular side. So for this particular prism, I would substitute 7 for base, 9 for height, and 10 for length, simplify, and find that I have an area of 273 units cubed. To find the volume of this same shape, I would use the formula the volume equals 1/2 the base times height times length. So this first part of the equation is really the area of a triangle. When I multiply that by the length of the prism, I get the entire volume. So I would substitute 7 for base, 9 for height, 10 for length, simplify, and find that I have 315 units cubed. A cone is a pyramid with a circular base. It has a radius r, and it has a side length which we refer to as s. Sometimes you'll see this in books or other places as called the slant. What's important is that we recognize that the side length, which is the length down the side of a cone, S, is different from the height. The height is the distance from the center of the base to the top of the cone. To find the surface area of a cone, we use the formula surface area equals pi r squared. This actually gives us the surface area of the circular base plus pi times r times the slant, because the slant represents the radius of the circle that is folded around to make the sides of a cone. To find the surface area of a cone with a radius of 7 and side 10, I plug in those dimensions accordingly, simplify, and find that I have a surface area of 374 units squared. To find the volume of a cone with a radius of 7 and a height of 8, I use the formula the volume equals 1/3 times pi r squared h. And you might recall that this is very similar to the formula for the volume of a cylinder. The difference is that a cone has approximately 1/3 the volume of a cylinder. So we use the same formula, but we have to multiply by 1/3. So I would, in this case, plug in my radius of 7 and height of 8. I would then simplify and find that I have a volume of 410.5 units cubed. The last shape we're going to look at today is a pyramid. A pyramid is a solid figure with a polygonal base and triangular faces that meet at a common point over the center of the base. That point is often called the vertex or apex of the pyramid. The base can be any polygon. There are pyramids which have triangular bases, rectangular, square, hexagonal, any polygon that you can imagine. For our purposes, we are only going to examine square-based pyramids. That means that the base is a square. To find the surface area of a pyramid with a base of 6 and a side of 10, that means that both sides of or all sides really, of the pyramid are 6 units in length. We use the surface area equals 2 times the base times the side plus the base squared. The base squared gives us this bottom square. 2 times base squared accounts for the fact that we have 4 triangles. The slant, the side here, 10, is really the height of each triangle, and the formula would be 1/2 the base times the slant. But since we have 4 times a half is 2. So I would plug in a base of 6 and a side of 10 accordingly, simplify, and find that I have 156 square units as my surface area. To find the volume of this pyramid, I use the formula 1/3 base squared times the height. This is very similar to finding the volume of a square prism, except that a pyramid is only 1/3 the volume of a square prism. So therefore there is a 1/3 at the beginning of the equation. I would substitute 6 for the base, 8 for the height, and when I simplify, find that this pyramid has a volume of 96 cubic units.